I can live a lie, running for my life. I will always want you. I came in like a wrecking ball.
All right, there's a little Kelly Cyrus for you coming in like a wrecking ball. Nice, Mr. Kelly. That's pretty awesome. Excellent. So 10.1, we're going to graph some rational functions, and I was trying to think of what's rational. Twerking. I don't know if twerking's rational. I love the twerk face there, Mr. Kelly. So I started looking for other twerkers out there, and I found this guy right here. Yeah, that's right, Mr. Bean. Mr. Bean can twerk while he teaches. He's a teacher twerker. That's incredible right there. And then I really got into this. I said, well, I'm going to Google, other teacher twerkers out there. Turns out Sullivan is the original twerker. This guy's been twerking for years. Holy cow, who would have guessed it? Check that out. Incredible. All right, moving on. We're starting a whole new chapter here, chapter 10. This is a great chapter. Top 10.1 reasons why you're going to love this chapter. We're doing 10.1. Why are we going to love this chapter? Number one, I'm not going to refer to twerking ever again. This is a one-time shot. All the twerk faces will be done after this one. Awesome. Number two, it's only 4 sections. Long-winded Sully and Kelly and Bean, they've been killing you with these big sections. We're going to tone it down a notch. 4 sections. Number 3 in the top 10.1 reasons is this is an oasis in what I like to call the Beanhara Desert. You may not know this, but Chapter 9 was Bean, Chapter 11 is Bean, Chapter 12 is Bean. Bean is wrapping it up here, and this is your only oasis, your only break from all that beanness, so you enjoy that. And the last reason, again, it's only 4 sections. Can't say that enough. It's only 4 sections. I couldn't actually come up with 10, but I think that's pretty good right there. So let's get this thing rolling. What are we talking about here? We're talking about rational functions. So we're going to look at graphing them. This whole one is about graphing them. Later on, we're going to simplify and solve them, do a couple different things. So first of all, we need to know what is a rational function. A rational function is just a polynomial divided by a polynomial. So no big deal here. We talked about them before. We're just going to divide something by something, a polynomial by another polynomial. This is the generic equation for this. So if I'm going to graph these things, here's the parent function right here. That means the most basic one possible. So this is the parent function. Well, what does it look like? Well, I went ahead and pre-graphed this for you. So if you look at this, in the red here is your actual function, the parent function. We've got these asymptotes in here. So the asymptotes happen right here, boom, right on the y-axis. And there's another one, another asymptote right here on the x-axis. So these are the asymptotes. They happen at 0, 0 in the most basic function. And then it just follows it right along, and we're good to go. So pretty cool. So if I ask you, what is the horizontal asymptote? Remember, horizontal asymptote is this one. It's a y. It means when y equals 0. And what's the vertical asymptote? It's when x equals 0. So again, there's our function. If you can't see it, there's our function. Comes in and it follows it down to infinity here. Comes from positive infinity all the way down to here. Awesome. All right, now that we get the parent function, let's go ahead and start moving that function around. So we kind of know what the most basic rational function out there looks like. Can we shift this guy around a little bit? Sure. If you think about the fraction, this is always a grouping symbol, the top of the fraction, bottom of the fraction. So that's a grouping symbol, and it moves just like every other function out there. So what does this mean? If you see minus 3, it's kind of opposite of what you would think. That's going to actually move it right 3. And then what is going to happen here on the outside? That's like going to be your up 5. So that's the vertical shift. So what are we actually moving? We're actually moving this point right here where the two asymptotes meet. So I'm going to go ahead and move that first. I'm going to move it right 3, up 5. I'm going to put a dot there. And then I'm going to go ahead and put in my asymptote. So the vertical asymptote, we'll slide that bad boy in. So it's going to be like this. And then the horizontal asymptote will go through like that. So we're always going to make our two asymptotes cross there, and then we can go ahead and draw the function in. So remember, just like this one, where it comes down from infinity over to infinity, we're going to come down and go something like this, and then we're going to do the same thing from negative infinity, come down here to negative infinity. So we've got this going on. So what is a horizontal asymptote? Well, we shifted it up 5, so it's y equals 5. Remember, that's the equation of this horizontal line. Vertical asymptote would be, we shifted it right 3, so it's when x equals 3. Awesome. Very cool. Let's do it again. Let's try another one. So if I look at this, can you just tell me what the shift is? Sure. I'm looking at it. It's going to go left 5. I mean, here it is. There's my left or right. And then over here, I'm looking at a down 2. So I'm going to move that point of intersection of my asymptote. So I'm going to move it left 5, down 2, and I'm looking at this point right here. Then I'm going to go ahead and let's bring these asymptotes in there. So I'm going to say, boom, vertical asymptote, boom, horizontal asymptote. And then it's just a matter of drawing it in there. And I'm honestly most concerned about drawing this and showing me where these two asymptotes cross. This part can be pretty rough right here. Like, I just want you to make sure, first you got to be in the right spot. You got to know it comes from up here, then it falls down out here, and the same thing from here to here. Because if you notice about this one, I actually changed this top number. So before it was always a 1, like back here and back here, it was a 1. You can plug some points to get these exact values, but all that number is doing is determining how close you get to this point of intersection. So as that number gets bigger, it actually changes the graph a little bit. I'm not too concerned about that right now. I just want to see the shift of the asymptotes, get the rough idea of which, make sure you're actually in the right spot for following the asymptotes, and you'll be good to go. So in this case, the horizontal asymptote is what? Well, we shifted it down 2, so it's y equals -2, and we moved it, what, left 5, so it's at x equals -5. So again, I'm most concerned about the asymptotes on this one. Alright, here we go. Let's do some more problems over here. Wait, what is that? Who is this creeper over in the corner? Yeah, there's Mr. Sullivan, original twerker. We get it, Mr. Sullivan. You're the best twerker ever. Let's take a look at this one. So if I just look at this, you know, I'm looking for the translation here. This is going to go left 4. So I see what's going to happen here, left 4. So no worries. It doesn't have a vertical shift, so it's not going up or down. So I'm going to move it 1, 2, 3, 4. Put a dot. There is no up or down. So go ahead and throw the asymptotes in there. So I can see, you know, here's the vertical asymptote. Here's the horizontal asymptote, just happens to be the x-axis, no problem. What's the problem here? Be careful, we've got a negative. So remember, the positive version was up here, so this is a reflection. That negative flips it. So instead of being up top, it actually flips it to down here. Boom, like that. Remember, this used to be in the bottom, so if you flip it, it goes into the top, something like that. So do I need to actually graph this to see what the asymptotes are? No. Hopefully you can kind of just take a look and say, sure. If I look at this, I'm shifting it down 12, so that's my horizontal asymptote. It actually went down 12. And then what's the vertical asymptote? I'm going to go what? It's -7, so I'm actually going to go right 7, so it looks like this. So if you want to make a rough sketch, you could say, oh, sure, I'll go ahead and just make a rough sketch and say that moves it down 12, right 7, and that's where my asymptotes are. If you want to do that, you're more than welcome to, but you don't need to sketch this. I'm hoping you can just look at it and say, oh yeah, I know where my asymptotes are. Awesome. How about this one? Give this one a shot. I try to trick you a little bit here. Does it move left or right? It doesn't. So the horizontal, the vertical asymptote is still 0. I didn't move it left or right because you're just dividing by x. But what I do here, I moved it up 9, so that's a horizontal asymptote. And again, this is a negative and flip, and the 5 would make it be farther away from where the two asymptotes meet. But that doesn't matter to us. We're just looking at where are the asymptotes. Awesome, very nice. Moving on, we're going to look at some crazy rational functions. Speaking of crazy, look at that picture at the bottom, man. There is the Brus family. Yeah, that's actually creeping me out, especially my youngest Oliver there. He should probably not be making the twerk face, or my daughter, or my other son. Creepy. Let's look at some crazy functions. So those are the most basic. That's as simple as you can get. You know, we're just moving that basic one down. Rational functions will look intense. We're going to have all kinds of asymptotes. You're going to have more than one asymptote, or some different things can happen. So let's put these in. So if I look at this graph, you kind of got to draw your own asymptote in there. So right there is an asymptote. Then if I put in, I have another asymptote, don't I? Right here is another vertical asymptote. So I've got two vertical. Do I have a horizontal? Sure, it looks like right here it goes off forever and ever and follows this line right here. So we've got a lot going on. So if you can draw that, let's go ahead and label these parts. Where are the horizontal asymptotes? Well, if I look at this, this looks like when y is -2, I have a horizontal asymptote. Do you see vertical asymptotes? Sure, they happen at 2 and -2. So I actually have two vertical asymptotes at 2 and at -2. Now, the other thing I want to talk about is intercepts. What is the x-intercept? Well, it's where it crosses the x-axis. So what happens here? It looks like it happens here. We're going to have to guess on this. So it looks like it's pretty close to 3. So maybe I think this x-intercept happens at like 2.5. So that happens at 2.5 comma 0. And then looking over here, that looks like at what, negative 2.2. I don't know. You can be off a little bit. We're just kind of estimating, again, comma 0. So I'm just kind of guessing where these cross. And then is there a y-intercept? Sure. Here's the y-intercept, and that one looks pretty good. It crosses at negative 3. So I'm going to give you some graphs and ask you to recognize all these parts of these graphs. We just talked about asymptotes, and now we're adding the intercepts in there. So hopefully we can do all of that. Awesome. Let's try this next one. So again, can we fill in these vertical asymptotes? It looks like right here, I'm going to plug one in. It looks like there's another one over here. Do I have a horizontal? You don't have to have one, but in this case, I do. It looks like I've got one right here, and I'm going to have to stretch this line out. All right, there we go. So can I fill in these parts? Sure. Let's start with horizontal asymptote. Where does it happen? Well, I see it right here. Boom. We're going to say y equals 1. Vertical asymptotes. I see one here. And up here, good sound effects for vertical asymptotes. That's going to be negative 2, and that's going to be positive 3. Fantastic. So again, I have 2 vertical asymptotes. What's going on with intercepts here? Can I see some intercepts? So x-intercept, where's it cross? I see it crossing here. Anywhere else? Yes, it looks like it crosses over here. So I'm going to say my x-intercept is at, that looks like negative 4.5. And we're just taking our best guess here, get pretty close to that, comma 0. You know, if I went over negative 4.5, up 0. And that looks like, what, 2.3, 2.25, 2.4. We're just kind of ballparking it. It's right in there. And again, that's up 0. So that's the x-intercept. Is there a y-intercept? Yes, I see a y-intercept right here. So it looks like that y-intercept's almost at 2. So I go over 0. Up about, I don't know, 1.75 is what I'm going to say. You can say something hopefully around there, and then we got it. Go ahead and got our y-intercept. Awesome. Let's keep this rolling here. Wow. Now I'm going to give you a bunch of rules. So those were crazy graphs. What makes those crazy graphs? Well, if you look at these 3 functions down here, that's what's going to make some crazy graphs. So I'm going to give you some rules. You need to write these down and have these and kind of know these rules. How do I find a vertical asymptote? So a vertical asymptote happens when the denominator equals 0. So jot that down. It really means the bottom of the fraction equals 0. So if I look at this this first one here, I'm going to go ahead and do that. Let's look at this first function right here. Well, how do I know when this bottom equals 0? So I'm looking at when does the bottom equal 0? Well, what do I have to do? I actually have to factor this. This should be, you know, what multiplies 32 and adds to negative 4. Ooh, my sign's wrong. Never mind. Let's change that. It should be x minus 8, x plus 4. So I factor the bottom. When does that equal 0? Well, what solves that? Negative 4 and 8. So that's going to tell me my vertical asymptote. So my vertical asymptote is at 8. So my vertical asymptote is at x equals 8. And where's the other one? It looks like it happens at x equals negative 4. So I'm going to have 2 vertical asymptotes. Excellent. How about this one over here? Let's just go ahead and find them all. Vertical asymptote over here, set the bottom equal to 0. Can I solve that equation? Sure. Just add 9 to both sides. So sometimes you don't have to factor. Add 9 to both sides. We're looking at 4x equals 9. Divide by 4. We're looking at x equals 9/4. So in this case, it's just solve it. When does the bottom equal 0? Why does that happen? Well, you can't divide by 0. You can't take something and divide it into 0 parts. Imagine taking $1 and dividing it by 0 parts. It's impossible. So that's why we get this vertical asymptote where it's impossible. The graph can't exist. How about this bad boy here at the end? I've got this. When does it equal 0? Well, what am I going to have to do? I'm going to have to factor it. So you can undistribute or pull out the greatest common factor, which is 3x. It divides both of them. So I'm left with x plus 7. And again, now what are my solutions? What solve this? Well, you know, if x equals negative 7 solves this, what makes this parentheses 0? You know, you can think of this like as parentheses. What makes it 0? Well, if x is 0. So if x is 0 or if x is negative 7, that's going to cause problems. Those are going to be vertical asymptotes. Awesome. So how in the world am I going to tell horizontal asymptotes? That's vertical asymptotes. That's great. How do I do horizontal? Well, it's a list of rules, and I'll kind of explain why they work. But really, we just got to kind of remember a couple different things. We've got fractions. That's what rational functions are. If the power on bottom is bigger, so if the power, we're talking about the degree here. So if the degree of the bottom, so this is x squared, you know, x to the 1. This is x to the 1. So if you look at this, this is a x squared versus an x to the 1. If this is bigger, you get a horizontal asymptote of y equals 0. The reason that is, if you think about what's happening as you go to infinity, you're thinking about taking an x value that's really, really big. So if I'm looking at this function as it goes out forever and ever and ever, I'm looking at x, it's like a million or a billion or a trillion. Well, if you square a trillion, it's going to go way bigger than if you just have a trillion on top. In fact, it's going to be, when you divide by this super huge number, it's going to force it to go to 0. So that's why the power, the bigger power kind of wins. Awesome. So how do I know what happens if the power on top is bigger? So now check this out. X squared is on top, x to the first is on bottom. Now you've got this trillion squared on top outshines anything on the bottom. Trillion's nothing compared to a trillion squared. So it's running off, so this means it actually has none. There is none, so the power on top is bigger. Awesome. What if the powers are the same, though? What if you have the highest power squared, and they don't have to be squared, it could be cubed to the fourth, to the fifth, whatever, but they're the same. How do I know? It's like, well, they balance each other out. A trillion squared over a trillion squared, you got to take the leading coefficient. So this is 1x squared, 3x squared. None of this matters out here. It's this squared. That's the biggest power matter. So what is this? This happens at 1/3. So you're going to have a horizontal asymptote at 1/3. Awesome. Let's see if we can do this. Oh, right. We got to find some intercepts too. So our goal is going to be not only find asymptotes, but find the intercepts. So how do we do that? More rules. This one is chock full of rules. If I want to find x-intercepts, what do I got to do? I just have to find x when y is 0. Think about what an x-intercept is. It's something like this. It's where it crosses maybe here and here. That's the x-intercept. Maybe it crosses in between here. There's your y-intercept. So remember, we're saying, what is this point? So if you want to find x-intercept, you just say find x when y is 0. If you want to find the y-intercept, you find y when x is 0. So I think probably the easier one of these is pretend x is 0, the y-intercept. So all I do is take my function and say, well, let's say y is 0. So take your function and put 0 in. Wherever there's an x, replace it with 0. So I'm going to start with a y-intercept. So I've got 0 squared minus 4 times 0 minus 32. And what happens here that's nice? Well, 0 times anything is 0, so that's 0, that's 0, that's 0. What are you left with? You're left with 3 over negative 32. So that's it. That is your y-intercept. So when x is 0, y is a negative 3 over 32. Crazy, but that is your y-intercept. Awesome. So how do you find the x-intercept? Well, the x-intercept is a little bit trickier. You're going to say find x when y is 0. So really I'm going to say when does this equal 0? So I'm going to pull that down here. I'm going to kind of cheat because I don't want to copy that again. And say when does this equal 0? Well, if it's just a plain old fraction, you don't have any plus or minus out here. You don't have any of that stuff that could shift it up or down. If it's just a plain fraction, if we can make the top equal to 0, the whole thing equals 0, because 0 divided by anything is 0. You have $0 divided by a million people, they all get $0. So the bottom doesn't matter if there's not anything out here. So when does 2x plus 3 equal 0? Well, you just have to solve it. When does 2x plus 3 equal 0? Subtract 3 from both sides, you get 2x equals negative 3. Divide by 2, you get x equals negative 3 halves. Now remember, you have to write this up as a point. It's not, if it looked like that, that's a line that looks like an asymptote. You're going to say, I'm going to go over negative 3 halves, up or down 0. Awesome. There are the rules. If you want to try the next one real quick before I do it, that would be great. You can pause it. All right, what'd you get? Did you get the same thing as this? Well, this is a little bit trickier here. If I want to find the intercept, so again, the y-intercept I think is a bit easier. You're just plugging when x is 0 in. So you've got 0 squared plus 5 times 0 minus 36 all over, well, what happens on bottom? Ooh, this is an awesome one. I'm glad I picked this one. You've got 3 times 0 squared plus 21 times 0. Well, what happens on bottom? You've got negative 36 on top. Those are just gone. This is gone. You have nothing on bottom. Can you divide by 0? No. This has none. You don't always have a y-intercept. That means there's an asymptote there. You have no y-intercept. So you can definitely have none for these intercepts. They may not cross at all. Awesome. How about the x-intercept, though? Is there an x-intercept? So let's go ahead and do what? Remember, you take this equation and you set it equal to 0. And again, it's good to go. It's a fraction, so I'm most concerned, when does the top equal 0? I don't care so much about the bottom. If the top's 0, the whole thing's 0. So if I factor, I hope this factors, it looks like this is what? X plus 9, x minus 4. And again, I want to know, when does the top equal 0? When's this going to happen? Well, it happens twice, when x is negative 9 or positive 4. So you actually have two x-intercepts, when negative 9 comma 0 or 4 comma 0. So don't be scared of that. You may have two x-intercepts. Can't have two y-intercepts. This is not a function, but you have none. So I kind of threw a little bit at you. So we don't need to graph it to see it. You can do it algebraically. So we're expected to do that bad boy algebraically. Can we put it all together? Yes, we can. Let's do it. Let's do it all. So find all the asymptotes, all the intercepts, then sketch a graph of this. See what happens here. Let's do it. So vertical asymptotes, remember what does that mean? It means set the bottom equal to 0. When does that denominator equal 0? Well, this is a special case factoring, yeah? You got to say x plus 3, x minus 3. That's what makes the bottom equal to 0. So if you can't divide by 0, we're looking at x is what? Negative 3 or 3. And I would go ahead and graph it, you know. Let's throw that in there. I'm going to do this one by hand. Boom. Negative 3 vertical asymptote. Positive 3 is another asymptote like this. So there's my vertical asymptote. Awesome. Later on, we will talk about some things that, some holes that can happen. But for now, we're not going to address holes. These are going to be vertical asymptotes. Awesome. How about horizontal asymptote? Well, remember it's those rules about power. So if I look at this, the power on top is 1, the power on bottom is 2, so the degree on bottom is 2. So what happens here? The power on bottom is bigger. That means what? We do have a horizontal asymptote at 0. That is not a 6. Holy cow. Let's make sure that that is a 0. So I'm going to throw that in this. There's my horizontal asymptote. So I know I can't cross there. Can I find some intercepts? Sure. X-intercept means what? If it's just a fraction, when does the top equal 0? You know, when does the top equal 0? If you solve this, add 5 to both sides. We're looking at 3x equals 5. So x is 5/3. And remember, you have to write it as a point. This is 5/3 x comma 0. So 5/3 is what? 1 2/3, which is 1.66666. So that's okay. So it's right there on the asymptote. And then the finale here, the y, is when x is 0. Gosh, there's a lot of rules. But if we do enough, I think you'll get them. They're good to know. So pretend x is 0. So we've got this equation. So we're looking at what? This is really negative 5 over negative 9. Or my y-intercept is 5/9. So 5/9 is not be something like this up here. Awesome. So we've got our intercepts, we've got our asymptotes. At this point now, it's cool to go to the graphing calculator to kind of get a double check and see what this is really doing. So if I go to my graphing calculator, I think I preloaded this in there. Oh gosh, I showed you already. Let's go back to y equals. When you put this in, remember it's a fraction. So it's the whole top being divided by the whole bottom. So you need these parentheses. If not, you're going to get, it's not going to look right. You need parentheses on top and parentheses on bottom. The whole thing, the whole top divided by the whole bottom. Then go ahead and zoom standard. If you zoom standard, it's going to give you a nice viewing window for this, and there's our graph. So you can see the asymptotes. The TI-84 is not going to, you know, we're not going to show the asymptotes in there, but you can see what's happening. I'm going to drag this into my screen real quick and then draw this. So it looks like it's coming from here down to there, and again, it can be rough as long as we're in the right ballpark. And you know, I forgot to mention this. Sometimes this freaks people out, but you are allowed to cross asymptotes. Like people are like, "Oh, I can't cross that." It doesn't matter what's happening here in the middle. I can cross it here in the middle. It's just as I go out to infinity, what's going on out here. Then it's going to kind of level out and go with it forever. But in the middle, cross it all you want. Now, vertical asymptotes we're not going to cross, but these horizontal asymptotes, don't freak out. That's legit. That's for real. You can do that. Awesome. Then this one's going to look something like this. That's the sketch I'm looking for. If you can do that, you're in business. That's everything right there. We threw it all at you. So good luck on the practice. Good luck on the match ticket. I hope it goes well. I'm going to wrap this up with another Wrecking Ball clip. If you know me, you know I love Kool-Aid. The Kool-Aid man from the 80s smashing through stuff. So perfect for Wrecking Ball. All right. Peace out.